Careers in agriculture are so important because agriculture really is the backbone of our country.
In the next 50 years, we need to grow as much food as we've grown in the last 10,000.
Every aspect of agriculture is trying to learn how we can incorporate more technology.
There are so many jobs relating back to agriculture that have to do with the sciences, the engineering, the math. And it's really eye-opening once you kind of start looking to see what those opportunities are. One misconnection about careers in agriculture is that only men have careers in agriculture. If I want to work in science or engineering or math, there's a job for me too, and that it's not male dominated. If you have a passion for it and that's what you want to do, that's what's important. It shouldn't matter about anything else.
I think that there's a couple misconceptions about careers in agriculture. One is that people think it's either higher tech or lower tech than it is. Some people are surprised that I still go to the field all the time. Those in-field observations are extremely important to my job. So come June, July, come tomorrow, I'll be out in the field making hands-on observations of how the crop is doing. But some people are also very surprised by the amount of technology that goes into a single seed. The fact that at this site we have several scientists with PhDs who work on developing new varieties of seed. To me, being a scientist means figuring out the right questions to ask, asking them in a way that I gather meaningful data and can make an accurate decision, and then making some sort of decision around that. So figuring out my hypothesis, testing it, and then taking action. And that's one of the things that I really love about having a career in agriculture. When we ask a hypothesis and we get an answer, it often results in a very tangible result, which is a product that's really helpful to our customers. So that's a really exciting part about working in this job. I come from a very non-traditional ag background. I went to high school in Los Angeles. I was 20 minutes from the beach. No one in my family, as far as we can remember, has ever worked in agriculture except for an interest maybe in gardening. And yet, once I expressed an interest in college in agriculture and started working in it, I couldn't ask for more friendly, more welcoming people. There's a lot of great opportunity available to us in agriculture to revolutionize it, but I'm not sure where that change is going to come from. And I think that's why it's really exciting that we have another generation of students coming who will be experts in soil science, who will be experts in big data, who will be experts in genetics that can help us innovate and move the field forward.
The things I enjoy the most about my job, number one would just be the awesome people that I get to work with. They're always challenging you to help them solve problems, which I think is a huge reason why, having that foundation in science and math really helps you be a better problem solver. And every client or farmer that I work with, they're always, that's why they come to you, is to have you help them solve one of their problems. I think for anyone that wants to have a career in agriculture or to be a veterinarian, they just need to have the passion, not just for the animals, but to know that a huge part of your job is working with the people who take care of the animals. And so you got to love both the animals and working with the people, and then have the desire to learn, whether you're like the top of your class in your science classes or whether you're really, really good at math. I don't think that is the most important part of it. What's most important is just that you have the passion and the desire to learn, and then from there, as long as you've got those two pieces, you can be successful. Every aspect of agriculture is trying to learn how we can incorporate more technology, and so whether you're really good at the IT stuff or whether you're really good at being able to take the IT pieces and incorporate that into our daily jobs on the farm, all that is endless, I think, in terms of the opportunities. So as a veterinarian, there are lots of different ways that I use science as well as technology every day. Just a couple examples would include, when we're talking with a farmer in terms of if you do have a pig that is sick and trying to understand just the physiology behind the sickness, and then from that trying to figure out the pharmacology to determine what's the best treatment to try to help make that pig feel better. Lots of science involved in that. Another example would be, if we're, concerned about a health challenge at a farm and we maybe take some diagnostic samples. If we send those off to a diagnostic lab, they're going to use a lot of technology as well as some science-based technology to try to help us determine, what are the diseases that are present on the farm. And then from there, I'll take that information and try to help the farmer, resolve those issues. Other examples too, just on the engineering side, every barn that any animal is in, oftentimes we'll try to get the best air quality. Sometimes we'll use, automated ventilation systems, and that's all about the physics, how air flows, making sure that we understand all those aspects just to make sure that the pig or any animal has the best environment to live in.
I think a misconception in agriculture is that we're uneducated and you don't have a lot of knowledge, which I disagree with. I am educated. I have an animal science degree with ag marketing and ag business minors, and I'm constantly keeping up with the technology and the changes.
2-3 hours going from field land transport. So basically what we had was we designed a single hitch that you could pull through the field, and then in a couple minutes hydraulically from the tractor without getting out. You can take the hitch from field land transport. You do have to get out and put a safety lock in here to make sure this you don't bump the lever so this wheel doesn't, or the cylinder doesn't retract. So anyways, that was kind of our big thing for that ethanol industry down in Iowa. So basically you get the PTO shaft. Okay, so that is...
It's Von Mises criteria?
Yes, yeah. So we basically simulated a cylinder in there.
Yeah.
And then we loaded it.
Yeah.
Okay, this is a caster wheel, so it's got vertical load and then it's got a twist on it. So those are the loads on there. And this is fixed, welded to the body.
Yeah.
And there's
the stress
stresses there. Yeah.
So it looks like if you spin it in, you had high stress down in here, stress concentration factor through here.
Yep. No, you're going to put a nice big weld on there,
Yep.
so you just add a 1/2 inch of material there.
So you don't have to worry about that too much.
Yep.
So your overall load, you're sitting about 19,000 psi. Your max is 38,000. Yield of the material is...
Those are 50 is yield. And
50,000.
again, you got to be a little careful on there because you're putting those nice big welds in there. But
Yeah, to add.
the average is somewhere in that
22.
22 range.
Okay. And,
So-
and you said yield of material is 50,000 psi?
Yep. Yep.
Okay.
So we got 2.5.
2.5 times safety factor. Is that usually
Somewhere.
your design intent?
That's usually what we go.
And you
somewhere.
design towards yield, right? Not
We
towards
do.
yes.
Yep. Yep. Yeah. We
Don't even want to fool around
No.
with ultimate because
No.
it's never even close to
Yeah.
ultimate. Yeah.
Yeah. Then you start getting
Then you get
deforming.